Hey, fifth grade super scholars. I really wanted to take today and make it a little different. I wanted to review some of the stuff that we have covered and you've explored on your own from my science lab. First and foremost, we learned that matter is anything that has mass and takes up space, just like this elephant that's taking up space and has a mass on top of that car. And matter is everywhere. Even air is made of matter. So if you imagine the molecules, the air molecules that are in the air, they're full of tiny atoms, and even air we know has weight. We talked about how we know air has weight, even when we reviewed that if you filled up a balloon, if you first weighed two balloons, you put them on a stick and it balanced, and the two balloons would be even because the rubber would have the same weight. But if you then filled one with air, now you would be weighing both the rubber and the air. That's one of the ways we could prove that air has weight, even when we can't see it. We've also talked about the states of matter. We've talked about solids, liquids, and gases. Those are the three states or phases of matter. A solid has particles, the atoms are so close together that they can't move. They're super tight, like right here in this picture. The atoms are so close they can't move. An example of a solid is ice. So is your desk, and so is a pencil, and so is a piece of paper. A liquid, there's enough space for the atoms to move around. They're still touching, but there's enough space for the atoms to move around. That's a liquid. A liquid takes the shape of its container like water does. So an example of a liquid is water. And then gas. I know my picture's hiding it a little bit, but gas is only held in its container by whatever the barriers are of a container. So inside of a balloon, if you put helium, that helium gas is only being held in there by the container, the balloon itself. If you thought about your classroom, the air that you're breathing is only being held in its container by the walls. The atoms in a gas are free to move about, all about the container. We've also talked about mixtures and solutions. Remember, in a mixture, you can see the different parts, like in this salad. And in a solution, you can't see the different parts, but they still are what they are. Lemon is still lemon, water is still water, and sugar is still sugar, even when you dissolve it. So when we think, does mixing sugar and water result in a new substance if we mix those things? Nope, they do not make a new thing. If you mix sugar and water, you have not created a new substance. You've made a solute. You've made a solution with a solute and something that is soluble. There was not a physical change or a chemical change. The water is still water. The sugar is still sugar. Although we did talk about physical and chemical changes. A physical change is something that changed something physically. Like in this picture, the different dandelions have only changed color. That's a physical change, how it changed physically. If I were to rip up a piece of paper, I've only physically changed the paper. It's still paper. A chemical change happens when something is no longer what it was before and you could never undo it. Once you've baked bread, you cannot unbake bread. Once you've fried an egg, you cannot unfry an egg. Once you mix vinegar and baking soda, you can never unmix them. They've created a new substance. So here's some examples of some physical, here's a physical change. It didn't, the ice physically went from a solid to a liquid, but it's still H2O. That is still water, right? But here's an example of how matter can neither be created nor destroyed. This wood is going to go through a chemical change. When you apply fire to wood, it's going to turn into smoke and ashes. That's a chemical change. It's chemically can never go back to being a piece of wood. But matter was not created nor destroyed. Right? Remember, that was the law of conservation of mass. Matter cannot be created nor destroyed. It's just turned into something else. Here's some examples of some chemical changes. Mixing two substances that do create a new thing is a phase change. This is vinegar and baking soda creating carbon dioxide. Here's another picture of baking soda and vinegar. That's a chemical change. You can never undo that. It's creating a gas, and the gas is causing all that air to come up and move the material. Magnesium reacts with dry ice. He's putting some magnesium in a little cup. There's dry ice inside of there. He's going to put the dry ice inside the magnesium. It's a little bit scary. I've been in the classroom when they've done this. Putting a lid on it. Turned off the lights, and it's glowing. It gets really hot. It's actually, the smoke alarm would be going off right about now if you were in a classroom. But magnesium and dry ice create a chemical change, a chemical reaction. Until all the gas is burnt up. Iron reacts with copper sulfate. This is actually just pieces of iron inside of water, and that's what we would call rust. Rust is a chemical change because a new substance is being created. Obviously, you can see it very clearly. These two metal bars are put inside water and left, and they're creating copper sulfate, so much so that it almost fills up that little tube that they were put in. Fuming nitric acid versus a glove. So he's just putting nitric acid on a glove. This is a chemical reaction. It chemically changes just from the glove mixing with the nitric acid. Mercury and thionate reacts with oxygen. So when you put mercury thionate in this little hole and the oxygen touches it, it looks like an octopus, but that is a chemical change. It's just chemically what's happening when that mercury touches the oxygen. Funny. It looks like an octopus. All right, so then we started getting down to, well, what are things made of? For example, let's think about this cake. What is it made out of? Sure, we talked about it's made of sugar, flour, eggs, water, baking soda. When we put them together, before we baked them, we only had a mixture, right? Once we did bake them, we had a chemical change because you can never unbake a cake. When you add heat to something, you have chemically changed it, right? But it is also broken down into smaller pieces. That cake is also made out of molecules of proteins, lipids, carbohydrates, and nucleic acids. Well, what is a protein and a lipid made out of? It's made out of atoms, sulfur atoms, phosphorus atoms, oxygen atoms, nitrogen atoms, carbon atoms. Here is a picture of a platinum atom. It required a very special microscope to be able to take that picture. So when you think about your cake being sugar and flour, which is molecules of proteins and lipids, which is broken down to atoms of sulfur and phosphorus and oxygen and nitrogen, carbon is this picture right here, which has 6 protons, 6 neutrons, and 6 electrons. That right there is a carbon atom. And that's what we're going to get into today is our periodic table. We're going to talk about how you know what the protons and neutrons are doing to tell us what we're looking at. Before we get started in today, I wanted to show you this very awesome website. I'll put a link in the, I'll actually put a link to that awesome website right in your Pear Deck for today. But check out this website because it's called Scale of the Universe, and it really helps you to get to see about the size of an atom compared to the size of an ant compared to a size of the sun. It's one of the coolest websites I've ever seen. Hey, 5th graders, I had a really good time teaching you physical science. I hope your brain is ignited and you're interested in getting to know more about science.